Hey, what's up everyone? In this video, I'm going to be showing you how to get our Megascan assets looking a lot better and closer to what we see here in Bridge. I know that a bunch of you have been struggling with this issue. The displacement map isn't quite working, so I'm going to show you how we can create our own LOD, a higher res LOD, and bake out some custom maps that we can use when we are texturing to get a bit more detail. So what I've done, I'm going to be using this asset here, which is rock sandstone. I just noticed that the LOD on this one is particularly bad. So I'm doing 8K texture resolution, not really worrying about that for now. FBX, here's the LODs. I am taking out pretty much all of the texture maps. Just make sure to check multiple normals and high poly source. I kind of leave this on by default now because it just gives you a bit more information to work with. So jumping into Houdini, we are going to make sure that our Megascan plugin is open. I'm not going to use scattering or the splitter or motion, enable LODs. I'm going to be doing this in Redshift. And what we're going to do is we're just going to hit export. We get a little successful notification. So here is our LOD. And what I'm going to do is I'm just going to rename this, say LOD 0. And then I'm going to hide it and export again. Successful. And I'm going to jump up here and say high poly source. Okay, and jumping inside, we are going to go into the asset geometry. Just move this stuff out of the way. It does this because it's a script that is running, so you just have to move it out. And then where this section is, just swap it out with the high poly source that we have downloaded. Let it load, and just see how much more detail is brought back. There we go. So much more detail that our other LOD is lacking. So we have our high poly source and our LOD 0. So what we now need to do is create a new LOD from our high poly source. So to do that, jump into the high poly source, and and what I'm going to do is, and what we need to do is forget about this transform. Okay, so I'm going to go right to the root, to the source of our LOD, and you'll notice that it's a lot bigger. So it's currently sitting at like 125 by 125. It's like 250 meters big. And they are doing this transform because Houdini works in meters. Other 3D packages like Maya and I think Cinema 4D work in centimeters. So they are actually just taking it back down to baseline. But I've noticed that we get more detail working from the source here. So, and you'll notice like there are a lot of triangles. So we're sitting at just under 500,000 primitives. And you know, if we get enough of these in our scene, it will chew up our RAM and VRAM. And I've had it in the past where Redshift just dies because there's too much information. So what we're going to do is I'm just going to throw down a convert node. Convert. I'm not entirely sure if this is necessary, but with some other assets, I've noticed that it forces this file to bring back like the UV, like proper UVs and proper normals and everything like that. So just for diligence sake, I'm gonna use this convert node. Just leave it as is, and then what we're going to do is throw down a poly reduce node. And before wiring it up, I'm just going to say percentage to keep is 50. I want to keep 50%. continue reducing within quality tolerance. I found this checkbox to be quite useful. It just, yeah, it computes it better. And then say use only original point positions. And that will just force it to try and adhere to, you know, like these little ridges and things like that. It will just try retain a lot more of that detail. Okay, so leave everything as is, wire this up, and let's view it. Takes a little while to cook, so I'll just let it cook. Cool, so there it's done. It has retained quite a lot of this information and detail, and you'll notice that we went from 500,000 primitives down to 67,000. So I think each asset will kind of be different. I'm just going with the 50% because it's been working quite well. So it's about twice the amount of primitives as our LOD, but we want that detail. So now what we're going to do is we're just going to type FBX and throw down a RUP FBX output like this. And I am going to just copy this, go in here, let's go to job, we go to geo. I have already written some out, and I just named it the same as the asset, because eventually, you know, we would copy this into our Megascan library path, just so that when we bring in the asset again for a different scene, we'll have the right naming convention and it will be in that folder. So for now, all I'm going to do is, let's just say low poly LOD 00 version 01. So we'll just keep it like that. Let's just put a FBX at the end. So we're going to be using this one, low poly LOD 00 version 1. Hit accept, and then let's say save to disk. So this process is quite quick. We should see in our geo folder there's the low poly, and it's 18 megabytes, so that's pretty chilled. So now what we're going to do is, I'm just going to hide this. I'm going to create a new geo node, and let's just call this LOD 00. Open it up, let's throw down a file, and let's go to grab our low poly LOD 00. Accept. And there we go. So now comparing that to our original LOD, but I'm just going to view the source here so that we can hide the transformation. So this is the LOD that Megascans brings in by default. You can see it's very round, not a lot of detail compared to our one here, which is a lot more detail. And it will be, you know, it's lighter weight. It's still double the resolution of the original LOD, but it's definitely better than 500,000 primitives. Other assets that I've done this for have had close to 1 million, and you can very easily eat up your RAM. Okay, so now that we have a higher detail mesh for our LOD purpose, what we are now going to do is let's create another geo node, and I'm just going to call this high poly source, and I'm going to jump into our original high poly source. I'm just going to copy this file and bring it into here, just so that we have like a default vanilla geo node with the assets that we want to use for our baking process. So here we go, same scale, and everything is all good. So we want to leave these enabled, both of them. And what we're going to do now is just create a RUP, so a render network, and let's jump inside, and then let's throw down a bake texture node. Okay, so now what we're going to do is we are going to bake out some new maps from the high poly to our low poly. And just to explain this a little better, for those of you who have been experiencing displacement issues inside of Houdini using Megascan assets, this is part of the reason. So the displacement map, the default map that we have, is, you'll notice if you look at the actual map, it's quite lifted and bright. You know, there's not a lot of range between the high. Actually, let me grab it for you here quick. So this is what the displacement actually looks like. It's currently in the red channel, so I'm just going to filter everything here. So you'll see that everything is quite bright. Like, you know, a regular displacement map, what you would expect is something more like this, maybe. You know, there's more variance between black, which is no displacement, and white, which is high displacement. So if you are looking at it like this, this is technically what's happening. So this is the default map. This is where our LOD is, but this is where the displacement map is. You see that when you start increasing the displacement map, when you start increasing the displacement map, your LOD starts to balloon, and it starts to swell up, and that's because it's pushing your LOD into the space that the displacement map is. And because the displacement map isn't right next to the LOD, because the displacement isn't like this, let me just zoom in here. It's not, you know, it should only push from where the white values are starting to increase. The black values should stay close to where the geosurface actually is. So technically speaking, that is essentially what's happening. So your asset is starting to swell up because it's being pushed into a different color space and a different level. So this this map isn't actually, it's not doing what we are expecting. So to navigate, like circumvent that, or generate something different, we're going to bake out our own maps, which should give us a better representation of where the displacement needs to be applied in space. You can see that our LOD here is in its kind of default position, and our high poly source is being pushed out in all of these different areas. So that is the information that we are trying to retain and apply back to the material. So just to jump into this, we have our high poly, we have our LOD, we need to assign our low poly now, our LOD 00, to the UV object, and then take our high res object, the high poly source, and assign it there. So now here we just want to keep this the same because it's using render tokens, which is actually beneficial for us. So what I'm going to do is, instead of saying hip, I'm just going to replace this with $job, and then I'm going to enable remove intermediate output. I'm going to change this to OpenEXR. I'm going to say tangent space normals. I'm just going to enable everything so you can see what we get. I'm going to do displacement, vector displacement, tangent space, vector displacement. This one doesn't quite work yet, but I'm just going to do it anyway. Occlusion, cavity, you know, we can do thickness and curvature and things like that, but I'm just going to do these ones for now. Okay, maybe let's just do all of them so that you can see them. And then under unwrapping, I'm just going to do UV match and leave everything the same. We can increase our pixel samples, but I just want to keep everything kind of default because we want to automate this process for you guys. So I'm just going to keep the resolution quite low, go to 2K, and then it's asking for a camera. So we do need this. So I'm just going to create a camera here. I'm going to remove all of the transformations just so that it's at the origin like that, and I'm going to change the resolution here as well to 2048 just to make sure that everything is in order. And then what we do is we jump out of here and go to our ROPNet. Everything looks like it is good, and then I'm just going to hit File, Save, and then say Render to Disk in Background. I've just noticed that if you hit Render to Disk, it doesn't open up the scheduler. I've already ran this out, so I'm just going to let this one cook just to make sure I have done everything correctly, and then I will show you what it happens, or I'll show you what the result is after about 5 minutes or so. Cool guys, so it's finished rendering. It took 9 minutes and 24 seconds, and that was because I enabled thickness and curvature, which I didn't do before. And keep in mind that, you know, when I first started testing this or did this, I would render out like the 8K maps, but that does take like over an hour. So just keep that in mind. Also, using 8K maps will chew up some of your GPU RAM, etc. So pick your poison, and you know, only use the 8K stuff when you are doing close-ups, etc., etc. Okay, so this is finished. And if we jump in here, here are all of our maps that we just baked out. So just to take a look at that, here is some of the texture maps. Here's the displacement map that it has baked out, and you'll notice that, you know, here we have a very nice, or as expected, range between black and white values. Compared to our original map, it looks quite different. So this is a noticeable kind of issue. I have recruited one of my friends at ILM who is looking at this issue as well, and he also kind of pointed out that it could be a color space issue, which it definitely looks like. So for now, I wanted to show you this method because it is it will help bring back some detail, but we are still refining it and trying to come up with the best method to automate it, so you won't have to go through this process every single time. Hopefully it will just be a shelf button that you can push. So here's the displacement, here's the normals, here's the occlusion. Look at all that nice detail. I mean, even this, you could try plugging this into the displacement. Just thinking that it definitely won't work as expected, but you never know. You know, here's the thickness. Let's see how. So, you know, bringing down the range. Look at all this nice detail that we just aren't necessarily getting. Here's the vector displacement, and I've noticed that this gives us quite a good result when we start rendering. Oh, here's the vector, what was it? Tangent space vector displacement. So I'll give that a go as well. So these are all of the maps that we now get that we can start plugging in for texturing when it comes to rendering. So we'll jump into that next, and just to explain this further, if you're working with the scaled down version, you'll notice that in the original version there is more range. So because the scale is bigger, the offset from the LOD to the original is bigger. So you see that there's a lot more range in between here. The scaled down versions, there's not as much range. So again, like as we saw when I compared the displacement, there is detail there, but the range is so squashed that it kind of looks like there's just nothing. It is there, but then we have to start tweaking it in post, etc., etc. So let's work off of the original scale. Okay, so guys, this was the first part of the tutorial where we created a new LOD, a higher res LOD that we can use for rendering and bake out some custom maps that we can use when it comes to texturing and rendering. So let's jump into that now. Okay everyone, so I've just set up a little scene here with a dome light and a little rim light here just so that we can see a bit more detail. I've set it all up so that I have all my ducks in a row for what I'm about to show you. And so this is the default LOD. Boo, looks very bad. This is our original high poly source. So there's a massive difference. And now this is our custom LOD with custom displacement maps. So, you know, comparing to the default LOD, we get a lot more detail. Comparing back to the high poly source, see there is still a little bit of difference. And that's why I'm still trying to refine the process to make sure that we can have kind of like a generic shelf button, which will get you close, you know, closer than what I am now. But as you can see, it's still so much better than the default, and also we rendered out 2K maps. So I'm sure if you render out 8K maps and give the baked texture a few more samples, we should be able to get a much better looking asset. And also, you know, when you do the poly reduce, instead of 50%, you can try 75% according to your needs. But as you can see, this process yields way better results than just the default. So I am going to quickly show you how I set this all up. So I'm going to hide what I've done. I'll just move this over to the side. So I just brought in the default LOD. I brought in our high poly source like we did before. Pretty much left everything exactly the same. Now what I'm going to do is just jump into Bridge. I'm going to export out a new version of the asset. Bring that into Houdini, which is over here. I'm just going to call this custom. Just call it custom for now. So jumping inside of here, inside of the asset geometry, I am going to move all this over again and go to our geo directory where we baked out. So these were the ones I did before. This is the one that I did in the recording. So bring that in. And you'll notice already a big jump in detail. Now, just jumping into the asset material, so everything's still plugged in. I am going to just remove these and duplicate it like this. I'll just put a box around it and say default. Now what I'm going to do is I'm just going to get rid of this. See, here's all of these additional normal and bump maps. I find like the default one, it defaults to like normal bump, which I don't find gives great results. I find the best results are with a good displacement and bump ratio. So I'm just going to duplicate this 3 times. Actually, so I'm just going to quickly take this displacement node. I'm going to jump in and choose the displacement that we baked out. So inside of here, render here this DS displacement. So I'm going to plug that in, and I'm going to wire this up to displacement. You can leave it as is because it is a height field. So there's our displacement. Okay. So what you need to do is go to the asset geometry, and you need to make sure that tessellation and displacement are enabled. It is not enabled by default, and I don't know why. So the displacement scale I'm going to take down to 0.01, and now if we render this, we should start seeing some detail. So there, we have some displacement happening. I am just going to enable and disable. I'm going to enable our original LOD so that we can compare, and just say always on top. I'll hit render again, and that's the comparison. You can see we already have so much more detail. It's lightweight, and we have displacement enabled, and it's actually giving us a decent amount of detail. Remember, it's 2K, so now just to kind of continue going, enable, disable, what I find is if we enable our, we enable our bump map, so I'm just going to go to the original bump. Come on. So this should just be, yep, just the bump map. Let's plug this in here, hit render again. And you'll notice it goes pretty crazy. So what I figured out last night, that just go down to the color multiplier, take this down to like 0.02, and you'll see it applies it to our edges, and it just sharpens up our edges a little bit, which is quite nice. And then to go a step further to give you guys even more detail, and I also find this just kind of takes the edge off of it a little bit. I'm just going to say disable. What I have been doing is throw down a RS max on noise. I'm just going to go to displaced turbulence. We're going to take it down to 0.1. I'm going to duplicate this because essentially it's just a black and white map, so it should be a height field. And then I'm going to hit tab and go blend, bump blender. I'm going to plug our original bump into the base, and then I'm going to plug this noise into layer 0. Let's just give it like 0.2. Let's say 0.25, just that we can see. And now I'm going to plug this into our bump and hit render again. And you'll see how we just get like a little bit more roughness to everything. It kind of takes the curse off of the asset a bit. You'll see like in places like this, I'm only at 1280, but you can see the difference. It just adds a bit more roughness. Like this is a rock. It's meant to be quite rough. So you know, we can still play around with like this roughness and specular and all of those things, but I haven't been recently. But you'll see we get a lot more detail, and then just to go a step further, we'll just do compare. I'm gonna enable disable. Let's re-enable our high poly source and hit render. And there is our high poly source. So you'll see that it is different, and there's also some shadow issues. So what's going on there? And to fix that, I'm going to enable disable out our high poly, go into our custom asset material, and that is because of the normals. So we want to just grab our normal map, because this one is normal bump. It's kind of a combination of the two. So we've already got our bump here. I'm just going to plug in the normals just as another layer like this. Plug it in there. Let's give it like a blend weight of 0.5. You know, just leaving it normal. It's a tangent space normal. And let's hit render again. So you'll see we start to get a little bit of that shading back. You know, you can increase the weight, but I find with the displacement and decent lighting, like you don't really need to bring it all back. I actually find some of the detail it brings out. So, you know, we can take our displacement and increase it a bit more. Maybe that's a bit too much. Just so that we get a little bit more detail. But comparing to that, I mean, there's quite a significant difference. And then, you know, and at least like our displacement, if I crank this, go say to about 5, see, it's not swelling up. It's actually doing what we expect it to do, and it's going from the original mesh here, and it's just increasing where it needs to increase, where the values are white and gray, and where it's black, it's staying close to the surface. So if I have to, if I had to now swap in the default displacement that we swapped out here, you'll see what happens. So there, it starts to balloon and swell up, and this isn't cool. This looks terrible, and it doesn't do what we are doing. Just to quickly end off, I actually realized something after watching this tutorial and editing it. So the displacement map is definitely in the wrong color space. It's in the log color space. So you'll see it's bright and lifted, like I mentioned before. And if I have to take a curve tool here in Nuke, which will just find our brightest max luma pixel, and it will also give us the minimum. So if I hit go, and then go here to the max luma data, you'll see the maximum is sitting at 0.6, and the minimum is at let's just call it 0.4. So it's been squished into like a 0.2 like range. So, you know, there's information here, but it's very squished together. Now, if I take a log to lin, which is essentially converting this displacement map from a log image to a linear image, you see how much detail we actually get back. Like, this is kind of what I am expecting to see with a default displacement map. So now if we run a curve tool on this, max luma pixel again, click go, and we go to our max luma data, you see that the it's now 0.6 to 0.1. I actually thought there was a better range. Okay, so we have opened it up a bit. So I'd probably still say that, you know, we would want to throw down like a grade and get those darks a bit darker, those brights a bit brighter. 0.5 and a 1.5, so gamma down, well, it's after the log. And go again. So there, we are close to 0 now, and we are close to 1. So we've now fit the original log space image into more of a linear space. So I just wanted to share this with you because it was only after I listened to myself explaining it, the penny suddenly dropped, and I was like, okay, it's in log space. So for the map that I baked out, I didn't, or re-rendered out, I didn't do this grade. So what I'm going to be showing you inside of Houdini is just a straight log to linear conversion like this. And I wrote that out as a displacement log to lin version like that. So jumping back into Houdini, this is our default high poly asset. Over here, this is our custom high poly asset, and so this would be our custom LOD and our custom displacement map that we baked out. So again, there is a fairly substantial difference between the two, like that. Still a lot more detail than the regular LOD. And then this is the original displacement map with the color space conversion. So this is using the linearized displacement map from Megascans and switching back. You can see we are way more in the ballpark. And it's swelling up a little bit like that because I did increase the displacement map here. So bring it back down to 1, hit IPR again, and we should get it a little bit closer. I did want just a little bit more out of the displacement map, so that is why I increased it a bit. But you'll see we are a lot closer to our actual original high poly source and what we have been seeing in Bridge. So this is compounded. So this is our setup here. This is the log to lin. This is the custom. So using that log to lin displacement map along with the bump setup that we created, we get a way better looking asset, a more lightweight asset, and something that we can actually start using in our scenes without worrying too much about RAM getting destroyed. But you see now that this displacement map is actually matching a lot closer, and even in the displacement map here, like, there is a lot of nice detail that we want to get out. It even looks like they added some noise to it and beefed it up a bit, which is really nice. So we do retain that detail, and then the bump maps. So if I had to disable the bump maps, a lot of nice detail and information is actually coming from the bump map, the bump and the normal maps. So keep that in mind, that the displacement will only get you so far, like this. But it's actually the bump and the normals which are just defining the details a lot better. So I just wanted to quickly share this with you because, again, I am still trying to refine this process, and it was only after I was watching the tutorial back that I realized I'm an idiot. It's in log space. It needs to be converted. Currently, we can't, I haven't been able to figure out how to do that inside of Houdini yet. Like I said, a buddy of mine is helping me out. I sent him a bunch of stuff last night. So what we're going to try to do is have a script that will bake out a new LOD, pull our displacement map into COPS, which is the compositing operators, do the log to lin transformation, and then write it all back out to the Megascan directory, so it's right there. Cool, just wanted to add this. So I'm going to wrap it up here. I really hope this helps a lot of you. I was quite taken aback when I noticed this issue, and I've been trying to figure it out or come up with some sort of temporary fix for the meantime. And I wanted to show you guys what I've done. We are going to try create a automated tool for everyone. And for all of you out there that are experiencing this issue, if you like and subscribe to the channel, I will let you know as soon as we come up with an automated tool. I'll show you guys how to install it, how to use it, just so that this process that we've done now is expedited and kind of sped up. So this is how I did everything. I really hope it helped you guys, and I will see you in the next video. Cheers.